In example 2, they have two instructions. They say to write first as a single trig ratio, then evaluate. So looking at A, we have to figure out one way to write this as one trig function. Right now it has two trig functions. It has a cos and it has a sine. So our job is to try to figure out how we could write this as a single trig function. Now, this is where formula memorization comes into play. Do we have a formula somewhere that's cos squared minus sine squared? Yes. Of our three double angle formulas for cos, the very first one is cos squared minus sine squared. So we can rewrite this as cos of 2 theta, and theta in this case is pi over 4. So it's cos of 2 times pi over 4. 2 times pi over 4 can be simplified to be cos of pi over 2. Then evaluate where possible. Is pi over 2 on our pi plate? What is the x-coordinate at pi over 2? 0. Part B. Technically, part B is already in a single trig function. It's only with tan. So we could evaluate it already. Pi over 6 is on our pi plate. Okay? But if we look at our formulas, because we're kind of like, this might look like one of my formulas, I see that my formula on my formula sheet says that tan 2 alpha is 2 tan alpha over 1 minus tan squared alpha. Can you see that it's very close to matching up to ours, but not quite? The difference? What we have in B has tan squared minus 1, and our formula has 1 minus tan squared. Okay? Maybe you want to add a little reminder to yourself that if you have A minus B and you factor out a negative, it's the same as B minus A. So I can rewrite the question that we have, here we go, as 2 tan of pi over 6, factor out a negative out of the bottom, and then I would get 1 minus tan squared of pi over 6. Some things about fractions and negatives. Do you agree that if you have a negative on the bottom of a fraction, it's the same as the negative on the front of the fraction is the same as a negative in front of the fraction? So the fact that I factored a negative on the bottom of my fraction, it's just like having a negative in front of this fraction. And if I put a negative in front of that fraction, then the fraction itself matches up perfectly with my formula. And I can change it to negative tan 2 alpha, and my alpha is pi over 6. Which is equal to negative tan, simplify this, pi over 3. Pi over 3 on your pi plate. Negative root 3. Now what I don't like about examples A and B as far as evaluating is in both examples A and B, and I'm just going to slide up here to the beginning, they use values that are already on your pi plate. You notice how we got 0 for A by using the formula? Well, pi over 4 is on your pi plate. What is cos of pi over 4? Root 2 over 2. you could have evaluated this right away. Root 2 over 2 squared minus what's sine of pi over 4? Root 2 over 2 squared. A little bit of mental math. This squared minus itself squared again should be 0. So what I don't like about these questions, A and B, is they gave you values that were already on your unit circle. So if you wanted to evaluate them, chances are you just try to do it directly right from the beginning. Then you'd have to simplify, but that's not too bad. So I'm going to add a C and a D. Here we go. And C evaluate and what I really like about C is that depending on what your brain sees first, can either make this a question worth 2 points or a question worth 9 points on the exam. Now when they put this question on the exam, they make it out of 2 points. But if you choose the wrong method, it should really be a 9-mark question. What's the wrong method and what's the right method? Okay? What happens with most students when they see this is the first thing they see is a pi over 12. And they trigger, ooh, we did pi over 12 questions. Right? That's where you define two things that add or subtract to pi over 12, expand it with the 4 things and simplify. A pi over 12 question is usually worth 4 marks. If you see this as a pi over 12 question, figuring out this one would be 4 marks, figuring out this one is another 4 marks, and then simplifying it all together is another mark, making it a 9-mark question. They never put 9-mark questions on the provincial exam. But if you look at it some more, you might also recognize that we have 2 sine alpha cos alpha. And if you have that formula memorized, you're like, hey, that's on my formula sheet. It's equal to, right? Sine 2 alpha is equal to 2 sine alpha cos alpha. And so I can simplify this just to be sine 2 times pi over 12. And that simplifies to be pi over 6. Is that on your pi plate? Yes. It's equal to 1/2. How much work was that? 2 marks worth of work. 1 mark for recognizing the formula and changing it, and 1 mark for evaluating sine of pi over 6. Way faster than doing 2 pi over 12 questions. Part D, one for you to try. Evaluate pi over 8. Definitely not on our pi plate. So since you're trying this one, I will just write down the answer for this one. You should get root 2 over 2. If you have trouble with that, call me over. And if you do get root 2 over 2, you can work on questions 4, 5, and 6.